Assalamualaikum warahmatullahi wabarakatuh. We are from group number 8. Today we would like to do a short presentation for our case study. My name is Muhammad Ashraf bin Nasrhan and my metric number is 197446. So first is introduction. The case study mainly focused on the 3 years double-story house that faced settlement crack on an internal concrete wall in the kitchen. The owner attempt to repair the crack by applying filler to the wall that has a crack. However, even if the owner fixed the crack with the filler, the crack still reappear. The crack on the house are usually related to the settlement of the foundation. In most cases, the crack are caused by the vertical movement of the foundation. This happened due to the soil type below the foundation could not accommodate the bearing capacity from the structure. Okay, next we move to the problem statement. Settlement cracks appear on an internal concrete wall in the kitchen and it keeps reappearing after being filled by a filler. Okay, now we move to the objective for this case study. So there are some objectives that we need to identify, which is to determine the possible causes of the crack, to determine the additional data needed to solve the problem, to determine the possible remedial measure to the crack problem, to discuss the existing management system and technologies on the crack problem, to identify the role of professional engineers. Okay, next, this is the visualization of the problem the appearing at the double-story house. So this is the picture that illustrates the crack pattern that appear at the kitchen. Okay, next.
Next, I will present about the causes of the cracks. So there are two types of cracks, which are structural cracks and also non-structural cracks. So normally, structural cracks are more truculent and do threaten the structural integrity of the building. They are often caused by the incorrect design, poor construction site, shallow soil chemical reaction of the construction materials, overloading, and differential settlement. So they are typically accompanied by problems like sticking doors or windows, slanted doors, and sloping floors. Generally, structural cracks are usually wider than 3 millimeters in width. There can be continuous horizontal cracks along the wall, vertical cracks, and also diagonal cracks. So next will be the non-structural cracks, less aggressive and do not threaten the structural integrity of the building. So they are usually the sign of aging and the changing in moisture content, thermal and weather condition. So it is caused by natural effect. So next will be our judgment for this case study. Our judgment is the type of cracks is the structural cracks. This is because due to the sign of continuous horizontal cracks along the wall and diagonal cracks, slanted doors and sloping floors provided by the appendix in the case study. This may due to the differential settlement as mentioned above, like differential settlement is because of the insufficient soil bearing strength and the load bearing capacity. So next will be the additional data required. So the first one is the depth and the width of the crack. Then the second one is the geological history, and the third one will be the water table level. So for the width and the crack, the depth and width of the crack UPV method can be carried out, which is the ultra pulse velocity method, because it's non-structural method. And then for the why do we need to get the second data geological history of the site is because it's important to know whether to determine whether there is the external force that could be causing the structural cracks. So the next one is the water table. This is important because it can affect the stability of the foundation. This can be determined by using the piezometer. Next. Then for recommendation of testing and field monitoring. So there are 6 tests which are pile integrity test, foundation settlement monitoring, and also the inclinometer monitoring. Then cracks meter, joint meter, hydrostatic level cell, tube meter. So for the first one, pile integrity test, it can be applied in order to determine the potential of the pile to have the defects. So for the foundation settlement and inclinometer monitoring, it can be used to measure the displacement in the ground and in structures that lay below the ground. So the 4th until 6th is the instrument that can be installed to measure the movement of the cracks and to measure the width of the cracks and also the movement of the building. Next, I will pass to the other person.
Assalamualaikum. My name is Muhammad Ahmad, Mathematics of Research and Mathematics. So I will continue to present about the structural stability and integrity. So first of all, what is structural stability? Structural stability is basically means that the structure is in stable condition. So what makes the structure in stable condition is basically the main factor that make the structure stable is basically concrete. It's because of the concrete. So concrete gives structure resilience against formation, strength, and rigidity. It is immobile in response to volume or environmental changes. So basically, in concrete, cracking is typically the first indication of distress. So, but however, the deterioration will occur first before the break shock. Okay, and the next. According to the house failure for the case study, the result is possibly a result of corrosion, fatigue, wear, or creep is such deterrence. So when the cracks develop in high stress area, fatigue failures basically will start. So when these cracks are subjected to cyclic loading, it will widen the cracks and suddenly will fail. So basically, this is the result of poor geometric design, metallization, maintenance. So as engineer, in order we want to evaluate the failure of the house, the assessment of failure must be performed. So basically, the factors of designing a structure can be taken into account by engineer is the performance of the materials, the stress analysis, and fracture mechanics need to be taken into account. So in order to keep integrity of the structure, we require for inspection and maintenance. So engineer could carry out inspection in order to find damage, in order to keep the integrity of the construction. So when the inspection have been carried out, we can analyze the house structural integrity. So basically, the method that have been used is non-destructive test, which is NDT. So basically, NDT is a testing analysis technique which we want to assess a materials component, structure, system properties for characteristic differences. So for the software analysis, basically we use PLACES to Division 20 software analysis tool. As can be shown in the table here, is the properties of the clay and soil as in the software. So basically, these properties can be found in documentary in the appendix. So for the studies, so for the pile foundation that we studied are basically located at the right end of the foundation plan. Yeah. And then, as can be shown here, this is the figure of the deformation model. So basically, it indicates the vertical displacement of the soil due to loading applied to the area. And then, basically, for the diagram for the before extension, the settlement of soil, is slightly lower than compared to the 1.5 meter extension. This is because the diagram of before extension shows the settlement due to the pile formation only. But as for the 1.5 meter extension, at the end of the right end of the figure is more higher depth compared to the before extension as we extend the structure, the kitchen extend for 1.5 meter. And then another object of the software is the schedule. So basically, it represents the intensity of the settlement occurring based on the kind of that range from gray to blue. So the loading from the pile foundations is the reason why the intensity of the settlement under the pile foundation is high in gray. So the condition happened due to the 1.5 meter extension kitchen, as can be considered as an overhang step, which give additional uniform load to the ground. Hence, it will provide additional settlement to the ground. That is why, as you can see from the figure, the red one is point on this section of the at 1.5 meter extension. It means that this point give high stress compared to other points. So it means that it makes the foundation is not stable. So basically, when the settlement is unstable, the crack will develop. So and then the crack will develop due to unstable soil settlement and the structure integrity as there is no additional pile foundation provided. That is why it become high stress here, and it will crack because there is no any additional pile foundation. And then for the relation between soil settlement and cracks. So basically, the terms that can relate about the soil settlement and cracks is called differential settlement. So differential settlement refers to a situation in which the supporting foundation of a building settles unevenly. So basically, it result in structural damage, and then the soil beneath the buildings, the soil beneath the building expands, contracts, or moves unevenly is basically the impact of differential settlement. And then it lead to uneven foundation settlement. So crack will occur. So this is because some soils are weak and highly compressible by nature, which means that buildings that build on them need special things as we want to spread the load over a wider area to make the foundation is settles in evenly. But in our case, there are no additional pile foundation. That is why it leads to uneven foundation settlement. So basically, we need special footings to spread the load of a wide area to make the foundation settlement evenly. Basically, crack will develop as a result of unstable soil settlement and structural integrity.
Now, I will proceed with the next part, which is the remedial measure. So there are a lot of remedial procedure for crack, and the possible remedial measure for this structural cracks the one is epoxy injection. So epoxy injection is a method that practically used for cracks as narrow as 0.05 millimeter. So this method involves 3 unbent holes at regular interval along the crack and seal the crack on the exposed surface before injecting the epoxy under pressure. So there are many types of epoxy available, and the right types of epoxy can help in repairing the crack without reducing the strength of the concrete. So the next one is crack stitching. So crack stitching is a method used to fill the hole in the brick, which makes it more stable and resistant to additional cracking. So this method uses a variety of rebar stitching material that are fitted and grouted in between fissures to rejoin and seal the bricks together. So crack stitching is inexpensive, quick to complete, and non-intrusive method. So the next one is push pier. So push pier are hydraulically driven pipe section that are driven through the unstable soil and then into load-bearing strata. So this system suggested for bedrock or load-bearing layer near the topsoil. So push pier can assist to elevate the building when it is installed, which can minimize the crack. And push pier can give a long-term solution without causing any disturbance or disruption to the building. And the next one is additional lime for soil. So this additional lime for soil can promote the pozzolanic reaction, in which the pozzolan material will react with the lime in water to form the cement compound. So these changes will produce a peat line or hydrated line, which can cause the soil to become drier and less sensitive to the water. So this can improve the stability and the strength of the soil, which can reduce the differential settling. So as the settling reduced, the possible crack also can be reduced. So based on all the suggestion, our group has chosen the most possible remedies for the problem. Are the additional line for soil and push pier. So this is because in order to prevent the crack from occurring, the differential settlement must first be addressed, or else the crack will reoccur again and again. So by adding the lime to the soil can be stabilized, and the push pier can be applied to lift up the building and minimize the settlement and crack. So in terms of economical, even though push pier might be high in cost, they can assist in the solution for both cracking and settlement. So it can also provide a long-term solution while creating minimal destruction to the structure. Meanwhile, addition of lime to the soil is considered as inexpensive. It is suitable to use as the slab that is placed beneath the building. So thus, the solution are worth considering as they are feasible. That's all from me. I will pass to the next presenter.
My name is Faradila binti Amaski, matric number 203699, and now I will present the existing management system and technologies in use that are not working. So there are 4 categories in total. The first one is legal. So on 1st September 2019, the Malaysian Limitation Amendment Act 2018 came into force, introducing these new laws as you can see on the slide. So based on this case, the owner bought the house 3 years ago, but the owner just noticed that there are settlement cracks. So the owner only had 3 years from the date of discovery of building cracks to file an action against the developer or contractor. But it can be seen that the existing law does not protect the unaware property owners. So if the owner, in this case, only just discovered the crack after 15 years, then the owner cannot commence any action because he has already exceeded the 15-year limitation period. Besides that, the illegal house renovations have also created many problems for local councils and house owners in Malaysia. Illegal house renovations are mainly due to unsuitable guidelines, the public level of understanding, the unrestrained small contractors, and the complicated enforcement procedures. So therefore, it is important that the renovation guidelines be restructured, but you must follow the local requirements as long as not to contravene with the Road Drainage and Building Act 133 and the Uniform Building Bylaws UBBL 1984. So the next one is from a cultural point of view. So the authorities ignore complaints from the residents frequently, and this slowed down the taking of action. So example can be seen in the case of residents in Taman Ehsan Jaya Panamaran, which they have submitted an official complaint to the authorities, but they have not received any feedback from the authorities even after several months. So this work culture needs to be stopped as they can induce more problems in the future. So as for societal point of view, based on the backyard photos presented in document 1B, it can be seen that some of the house owners extended their kitchen by 1.5 meters horizontal expansion. So for horizontal expansion, crackings might occur due to different consolidation and settlement of both new and existing structures. So the different rate of settlement will cause cracks along the walls and floor. So if vertical extension of the existing house is being done without checking the capacity of existing conditions, the load of extension will cause settlement. So the cracks will start to appear. The same problem was faced by Batumala and his family when they had to leave their house after large cracks started appearing. He alleged that the cracks started appearing after one of his neighbors did a vertical expansion. So this shows that extension of any part of a house certainly can cause crackings on the walls and floors. So the next one is technological point of view. So in Malaysia, the technologies used to detect building cracks are mostly traditional measurement tools, which are magnifier, width tester, and others. However, the usage of traditional technologies produce low efficiency. So this should be overcome by using a more advanced technology like image processing technology or UAV. So based on my findings, there is a new crack with measurement method based on image processing technology. That is by using double square artificial markers to identify building cracks. So as well as calculate crack width. So the authorities should allocate money for more advanced technology in order to ensure work can be done more efficiently. So for the next part is role of professional engineers. So these are the roles based on this case, such as discuss with the client or owner, check whether the client makes any complaints, conduct a site inspection, check the present use of the structure or any change in the usage of the building, photograph the building cracks and nullender, collect samples from the site, monitor and measure the movement of cracks, find the suitable techniques to repair the building cracks, and the last one is provide a comprehensive report to record every crack, suspected cause of cracking, and techniques used. So, however, in any kind of situation, engineers must be professional and follow code of conduct as well as code of ethics. So in this case, engineers should always follow Regulation 24 in Code of Professional Conduct of Registration of Engineers Act 1967, revised 2015, which stated in the slide. The engineer shall be responsible for receiving any illegal action from the client if he fails to satisfy this code of conduct. So that's all from me. I will pass to the next presenter.
Now we move to the last part for the case study, which is conclusion. In conclusion, the objective of this case study have been achieved. Cracking is usually the earlier sign of the distress in the concrete. The settlement crack on an internal concrete wall in the kitchen must be resolved to prevent unwanted things from happening directly. There are various causes and solutions to repair structural and non-structural crack. To avoid being repaired repeatedly, the sources of the crack must be determined before starting the treatment. Professional engineers play an important role in solving this problem because they have knowledge and experience to solve the crack problem. Okay, that's all from us. Thank you.